Hello students, welcome to the channel. In this video, we'll solve the science section of the special testing form ACT April 2021 Z04. So let's begin. Passage 1. In a particular playa, relatively flat dry desert basin, evidence shows that some large rocks have moved along the surface, leaving shallow trails in the clay sediment, some up to several hundred meters long. Three scientists provided explanations for how these rocks moved. Scientist 1. In the spring, snow melt from surrounding mountains runs downhill and collects in the playa. At night, cold temperatures cause this water to freeze around the rocks. When temperatures rise again, the ice begins to melt, leaving a layer of mud on the surface and ice rafts around the rocks. The buoyancy of the ice rafts floats the rocks on top of the mud, such that even light winds can then push the rocks along the surface. Evidence of this lifting is seen in that the trails left by rocks are both shallow and only about two-thirds as wide as the rocks themselves. Due to the combination of ice, mud, and light winds, the rocks are able to move several hundred meters in a few days. Okay, so the first scientist gives the picture of snow melt collecting in playa, which freezes at night, and when the temperatures rise, it begins to melt and leaves a layer of mud on the surface and ice rafts around the rocks, right? And since the ice rafts are buoyant, they float the rocks on top of the mud such that even light winds can push the rocks along the surface. So it's a combination of all of these factors that results in the rocks moving several hundred meters. Scientists too, snowmelt from surrounding mountains does collect in the playa during the spring. However, the temperature in the playa does not get cold enough for ice to form. When the playa's surface gets wet, the top layer of clay transforms into a slick, muddy film. In addition, dormant algae present in the dry clay begin to grow rapidly when the clay becomes wet. The presence of mud and algae reduces friction between the rocks and the clay. Even so, relatively strong winds are required to push the rocks along the wet surface, forming trails. Due to the combination of mud, algae, and strong winds, the rocks are able to move several hundred meters in a few hours. So here the explanation does not relate to the freezing of ice and the melting of ice, because the scientist believes that temperature does not get cold enough for ice to form, right? However, there is the possibility of clay transforming into a slick film and dormant algae beginning to grow rapidly when the clay becomes wet. And that combined with strong winds results in the movement of rocks. So some points of difference to note between the first and the second scientists' testimonies are obviously the temperatures and also the speed of the winds, right? Scientist 3, water does collect in the playa, producing mud and ice. However, neither mud nor ice is responsible for the rock's movements. The playa is located along a fault line between tectonic plates. Minor vertical shifts in the plates cause the rocks to move downhill, leaving trails. Due to the combination of tectonic plate movement and strong winds, the rocks are able to move only a few meters over several years. Okay, so this scientist is focusing on tectonic activity and how that is responsible for the movement of rocks. He also believes that strong winds carry the rocks, but they move only a few meters over several years, right? So he's different from the other two in that the first person thought that they moved several hundred meters in a few days. The second person said that they moved several hundred meters in a few hours, while here the timeline is in years. Okay, according to scientists too, friction between rocks and clay is reduced by which of the following? So that would be mud and algae only, because you know that it is the presence of mud and algae reduces friction. So it's D. Suppose a researcher observed that wind speeds greater than 80 miles per hour are needed to move the rocks in the playa. This observation is consistent with which of the scientists' explanations? So we are talking about strong winds, right? So both scientist 2 and scientist 3, their views are supported by this. Suppose that no seismic activity was recorded in the playa when the trails left by the rocks are found. This finding would weaken which of the scientists' explanations? So that's only the third scientist, right? Because he's the only one who believes that the fault line between tectonic plates is responsible for the trails, right? So question 4. Suppose it were discovered that a particular rock formed a 200-meter long trail in 72 hours. Would the discovery support scientists' one explanation? Several hundred meters in a few days. So 72 hours is 3 days, right? So it does support his explanation. Yes, he indicated that rocks can move several hundred meters in a few days. So it's G. All right. Suppose that during 1 year, there was no measurable movement of any rocks in the playa during the spring. Scientists 1 and 2 would most likely both agree that this was due to the absence of which of the following factors. So you know that, yeah, it's about the surface getting wet, right? So it is snow melt in both cases. So snow melt is the common factor between them. In the first case, the snow melt gets frozen. In the second case, it doesn't, but it's the common factor. So the absence of snow melt is common to both. Suppose that air temperature in the playa varies between 4 and 47. Would this information support the explanation of scientist 2? Yes, because if it's between 4 and 47, then ice cannot form because ice forms at 0 degrees centigrade. So it supports scientist 2's. Yes, because ice cannot form in that temperature range. And that is exactly what the second scientist was saying. Based on scientist 1's explanation, a rock trail that is 33 centimeter wide was most likely made by a rock with approximately what width? Okay, so evidence of this lifting is seen that the trails left by rocks are both shallow and only about 2/3 as wide as the rocks themselves. So the width of the trails is 2/3 the width of the rocks. So if the trail is 33, then that's 2/3 the width of the rock, which where let the rock's width be x. So x is 33 into 3 by 2, which is 99 by 2. So that's almost 50, right? So C. Okay, second passage. When certain substances are added to diet cola, CO2 gas is produced, generating a foam. 2 experiments were done to study this process. In each trial, an apparatus like that shown in figure 1 was used as follows. A jar was nearly filled with H2O and fitted with a 2-holed lid. Okay, so this jar is filled with water and then fitted with a 2-holed lid. One end of a tube, tube B, was inserted through one of the holes and submerged. The other end of the tube B was placed in an empty graduated cylinder. Another tube, tube A, was inserted through the other hole in the lid. A certain solid substance was inserted into the other end of tube A, and the substance was secured by a clamp. Okay. Tube A was then attached to a freshly opened bottle containing 355 ml of Diet Cola. The clamp was removed, releasing the substance into the Diet Cola. The foam that was produced traveled into the jar and liquid was transferred into the cylinder. The mass of CO2 produced was calculated based on the volume of liquid that was measured in the cylinder after foaming had ceased. Okay. Experiment 1, in each of trials 1 to 4, a different one of 4 substances of equal mass, a piece of chalk, a sugar cube, fruit flavored piece of candy, or a mint flavored piece of candy was added. And then these results were produced. And in the second experiment, in trials 5 to 8, trial 4 from experiment 1 was repeated, except that the temperature of the Diet Cola was different in each trial. Okay. If another trial had been performed in experiment 2 and 450 ml of liquid had been measured in the cylinder, the temperature of the Diet Cola in this trial would most likely have been. So the volume of liquid in the cylinder is 450 ml, right? So it's here. It's below what we have observed, right? So we see that as the temperature goes up, oh, sorry, this is not the correct place for that. 1 second, I'll just cancel this. It's actually here. Yeah, so as the temperature is going up, the volume of liquid in the cylinder is going down. So the temperature should be between 45 and 60, right? Between 45 and 60. Suppose trial 6 had been repeated, but the bottle of Diet Cola had been opened and then left undisturbed at 25 degrees centigrade for 12 hours before it was attached to the apparatus. Would the mass of CO2 produced in this trial likely be greater than 0.969 or less than 0.969? So you know that if the cola bottle has been kept aside before it is used in the trial, then a lot of its fizz would evaporate. So the mass of CO2 produced would be less, right? Because over the 12 hours, the concentration of CO2 would have decreased. So it's option C. 1 millimole of CO2 has a mass of 0.044 grams. How many trials resulted in the production of at least 1 millimole of CO2? So the mass of CO2 should be at least 0.044 grams. Okay. So how many trials? So definitely all these, in fact, all of them, right? All of them have a mass greater than 0.044. So all 8 trials. Yeah. Because 1 millimole is 0.044 and all of them have a mass produced greater than 0.044. Okay, according to figure 1, which of tube A and tube B, if either, had at least one end submerged in a liquid before the clamp was removed? One end submerged in a liquid, right? So that's only tube B, not tube A. So it will be tube B only. If is the relationship between the volume of liquid in the cylinder at the end of the experiment and the mass of CO2 produced a direct relationship or an inverse relationship? So the volume of liquid in the cylinder and the mass of CO2 produced. So so you can see that it is, let's look at the second table. In the second table, there is a decrease, and so you see a decrease here also, right? So it's a direct relationship. As the volume of liquid that was measured in the cylinder increased, the mass of CO2 produced also increased. So it's F. Consider these steps that were performed in each trial. Removing clamp, measuring liquid in cylinder, inserting a solid substance into tube A, attaching tube A to a bottle of Diet Cola. What was the sequence? So you first insert a solid substance into tube A. Then you attach tube A to a bottle of Diet Cola. Then you remove the clamp and let the solid fall into the bottle. Right? And then you measure the liquid in the cylinder. So it would be 3412. 3412, option B, right? Assume that room temperature is 25 degrees centigrade. In how many trials was the Diet Cola tested at a temperature lower than room temperature? Okay, so what was the temperature? Hmm. Right. So in the first case, it was 3 degrees centigrade, right? So there were 4 trials. And in the second case, it was these 3 were room or higher. So total 5 trials had a temperature lower than room temperature. 5. Okay. Passage 3. Scientists studied the effects of pH and of nickel concentration on plant growth and on the uptake of iron and zinc by plants. Recently germinated seedlings of species M and species U were fed one of 12 nutrient solutions for 8 days and then were harvested. Solutions 1 to 12 differ only in pH and or nickel concentration. Table 1 shows for each species the average dry mass of the plants that were fed each nutrient solution. Figure 1 shows for each species the average iron content and the average zinc content of the plants that were fed solutions 1 to 4. Okay. According to figure 1, as the nickel concentration in the nutrient solutions increase, the average iron concentration of species M. Okay, so let's look at species M. Species M is this one. So as the nickel concentration increased, the average iron concentration decreased, right? Decreased only. This one, I'm looking at this graph, right? So this is where you have species M. According to table 1, the species U plants that were fed the solution that had a pH of 6 and a nickel concentration of 10 micro M had an average dry mass of species U. So we are looking at micromoles per liter. Okay. So this is species U, the last column. And here I'm looking at pH 6 and nickel concentration 10. So pH is 6 and nickel concentration is 10. So that's 8.1. 8.1. Okay. According to table 1, species M plants that were fed a nutrient solution with which of the following combinations of pH and nickel concentration had the greatest average dry mass, right? So we are looking at 6 and 5 pH and 0 and 5. Okay. So species M, we are looking at 6 and 5. So these numbers and these numbers. So we are looking at greatest average dry mass. So greatest average dry mass is for pH 6 and nickel concentration 0. pH 6 and nickel concentration 0, option A. According to table 1 and figure 1, the species M plants that were fed solution 3 had an average zinc content of, okay, species M plant which were fed solution 3. So we are looking at this one. 23.8 was, so nickel concentration was 10. Nickel concentration was 10. And there, this comes to 100, right? Wait, oh, I didn't check that. Oh, this is iron concentration. Zinc is the white one. Okay, so iron decreased. Yeah, okay. Zinc is the white one. So zinc is actually 200. Yeah, zinc is 200 at that concentration. Yeah. Okay. According to table 1 and figure 1, for the species M plants that were fed solutions 1 to 4, what was the order of the nutrient solutions from the solution that resulted in the lowest average iron content to the solution that resulted in the highest average iron content? So 1 to 4, we know that the nickel concentration increased like this, but the iron concentration for species M went down. So the lowest would be 4, then 3, then 2, and the highest is 1. From what was the order? Yeah, lowest to, so that's 4, 3, 2, 1, right? Just let's verify that once. 4, 3, 2, 1. Yeah, lowest to highest. According to table 1, compared to the average dry mass of species U plants that were fed solution 3, the average dry mass of species M plants that were fed solution 6 was approximately. So species U and solution 3. Species U solution 3 is 9.6. So I'll just write that. This is 9.6, and species M solution 6. Species M solution 6 is 28.8. So this is 28.8. So this is 9 into 3, 27, right? So I would say 1/3 as great, right? Species U is 1/3 as great as species M. Okay, passage 4. Ammonia, NH3, can be produced according to the chemical equation. Nitrogen plus hydrogen gives ammonia. The equilibrium arrow indicates that this reaction proceeds in both directions until it is at equilibrium, so that both the forward reaction, production of ammonia, and the backward reaction, production of nitrogen and hydrogen, occur at the same rate. Equilibrium can be shifted forward or backward by changing the temperature, pressure, or concentration of reactants or products. 2 experiments were done using the following apparatus to produce ammonia. Okay, so these are the 2 experiments which we are going to describe here. In each trial, steps 1 to 4 occurred. A fresh catalyst, catalyst W, X, Y, or Z, 160 grams of hydrogen and 745 grams of nitrogen were placed in the reactor. The hydrogen and nitrogen reacted at a constant temperature and a constant pressure until equilibrium was established. A mixture of ammonia and any unreacted hydrogen and nitrogen flowed through pipe A to a minus 50 degrees centigrade condenser at 1 atmospheric pressure. Ammonia condensed and exited the apparatus. Hydrogen and nitrogen do not condense at minus 50. Any unreacted H2 and N2 flowed into pipe B, returning to the reactor. Okay. Experiment 1, a set of 9 trials was conducted with each of the 4 catalysts. For each set, the pressure was 150 atmospheres. Within each set, the temperature was different for each trial. Figure 1 shows for each trial the number of cycles of steps 2 to 4. Steps 2 to 4. Okay, so that means that how much time did it take for equilibrium to reach? And that's what we are. So the number of cycles increases as the temperature increases. So equilibrium takes more time, right? Experiment 2, 4 sets of 9 trials, each were conducted with catalyst Z. For each set, the temperature was different. Within each set, the pressure was different for each trial. Figure 2 shows for each trial the amount of ammonia produced in the first cycle of steps 2 to 4. Okay. Diagrams and figures adapted from Jayant Modak by the Indian Academy of Sciences. Okay. According to the results of experiment 1, for any given catalyst, as the temperature were increased, the number of cycles needed to complete the reaction. So you can see that as the temperature was increased, the number of cycles also increased, right, for any catalyst. So it's option A. In experiment 1, 26 cycles were needed to complete the reaction at 450 degrees centigrade when which catalyst was used. So 450 degrees centigrade and 26 cycles, right? So that is the triangle, which is catalyst X. G. The movement of hydrogen and nitrogen through the apparatus as steps 1 to 4 occurred is best represented by which of the following expressions? From the reactor, uh, they go to pipe A and then into the condenser and then to pipe B, right? So reactor, pipe A, condenser, and then pipe B. So that's C. Consider the result of experiment 1 for 375 degrees centigrade. All the hydrogen and nitrogen were consumed in less than 20 cycles when which catalyst was used? Less than 20 cycles. Okay, so 375 is here. All of it was used less. What is this showing? The catalyst. All the hydrogen and nitrogen were consumed in less than 20 cycles. Okay, so that would be all four, right? Oh no, not this. Sorry, we are looking at, this is the one. This is 375. So that would be except for the circle. So that's X, Y, and Z. Catalyst X, Y, and Z only. Option J. If a trial had been performed in experiment 2 at 425 degrees centigrade and 225 atmosphere, the amount of ammonia produced would most likely have been. Okay, so I'm just going to write those figures: 425 degrees centigrade and 225. 425 degrees centigrade and 225 atmosphere. Okay, so 225 atmosphere is this. And okay, so if it's, we are looking at 425. So we're looking at between 400 and 450. So at 400, you get about 400 degrees centigrade, you get about 360, I would say, 360 kilograms of ammonia. And at 450, you get the star, which is about, I would say, 220 kilograms. So a temperature between them would be between 220 and 360. Between 230 and 320. Yeah, those are the numbers that are closest. At 1 atmosphere of pressure, the melting point of ammonia is minus 77 and the boiling point of ammonia is minus 33. Based on this information and the description of the apparatus, when the ammonia exited the condenser, was it more likely a liquid or a solid? So when it exited the condenser, the temperature was minus 50, right? So it is minus 50 when it exits the condenser. Now, minus 77 is the melting point, and minus 33 is the boiling point, right? So it is, was it more likely a solid or a liquid? So it is definitely, it's a liquid, right? At this stage, because it has already melted at minus 77. So at minus 50, it is definitely a liquid because the temperature of the condenser was higher than the melting point of ammonia. The temperature of the condenser, yeah, it was between the melting point and the boiling point. So J, yeah, it's liquid because it's between the melting and boiling point. Consider the trial in experiment 2 that produced 550 kilograms of ammonia. Based on figure 1, the number of cycles that were needed to complete the reaction in this trial was most likely 550 kilograms, right? So 550 kilograms is this one. So that happens at 150 atmospheres. 150 atmospheres and 300 degrees centigrade, right? So 150 atmosphere and 300. So how many cycles are needed? This is catalyst Z. So catalyst Z was the star. Temperature is what? Temperature is 300, right? 300, and we have the star. So how many cycles? It's about 2 cycles only, right? Less than 5 for sure. Yeah. Okay. Passage 5. As a sound wave travels through a medium, the wave becomes attenuated. That is, it loses energy. The attenuation coefficient alpha is the rate at which the wave's intensity level, a measure of sound volume, decreases with distance as a result of this energy loss. The greater the value of alpha, the greater the decrease in intensity level with distance. Figure 1 shows for waves of 3 different frequencies in hertz how alpha in decibels per kilometer varies with temperature in air at 10% relative humidity. Figure 2 shows for waves of 3 different frequencies how alpha varies with relative humidity in air at 20 degrees centigrade. Okay. What is the approximate maximum alpha shown in figure 1 for a 200 hertz sound wave in the air at 10% relative humidity, and approximately what temperature does that maximum occur? So we're looking at 200 hertz, right? So 200 hertz is this, right? So what is the maximum that happens? Maximum is alpha is about 3, and it happens at a temperature 1, 2, 3. It happens at -5. So 3 alpha is 3 and -5. Yeah, alpha is 3 and -5. F. Based on figure 2, the attenuation coefficient for a 1000 hertz sound wave in air at 20 degrees centigrade reaches a minimum value at a relative humidity closest to which of the following. So minimum value for 1000 hertz, right? So 1000 hertz, and I'm looking at a minimum value. So I think it's here somewhere, right? 40%, about 40%, because that's where alpha reaches a minimum for 1000 hertz. Yeah, so I'll go with 45 because, yeah, 40 and 45 is, yeah, it's definitely that. So 45. Okay. For the range of temperatures and the range of relative humidity shown in figures 1 and 2, is alpha for a 200 hertz sound wave more strongly affected by a change in temperature or by changes in relative humidity? So 200, right? So if you look at 200 hertz, when you have a change in temperature, this is the pattern that we get. And for relative humidity, this is the pattern that you get. So you can see that the relative humidity doesn't really change much, right? It's like the range is really less, but here the change is much more. So temperature variation changes it more. It is more strongly affected by temperature because the maximum variation in alpha is about 0.5. No, it's about 2.5 with temperature, but almost only 0.5 in figure 2. Yeah, so G, because temperature variation is greater. Okay, consider a 1000 hertz sound wave in air at 10% relative humidity. At how many of the temperatures shown in figure 1 does alpha for this wave have a value of 18 decibel per kilometer? Okay, so 1000 hertz sound wave at 10% for how many temperatures? 18 decibels. Okay, so 18 decibels is this line. Right, so how many? 1, 2, 3, 4. There are 4 temperatures at which that happens. Okay, suppose that 2 sound waves, a 150 hertz wave and a 1100 hertz wave, are simultaneously emitted from a speaker into air at 20 degrees centigrade and 45% relative humidity. Based on figure 2, as the waves travel away from the speaker, the intensity level of which wave will more likely decrease at the greater rate due to attenuation. Okay, so we are looking at 45% humidity and 150 and 1100. Okay, so see, obviously 150, we can look at the 200 one, and for 1100, we can look at the 1000 hertz one because those frequencies are closer. And at 45, when the relative humidity is 45%. So this is what we are looking at. Right. So 45% relative humidity. So we can see that at 45% relative humidity, alpha for the 1100 one is greater than alpha for the 151 because this is close to alpha for the 1100 one and this is close to alpha for the 151. So the 1100 one will attenuate more. It will decrease at a greater rate. It's the 1100 because the value of alpha is greater for this than for this, right? So it's J. The graph below shows for sound waves of 3 different frequencies how alpha varies with relative humidity in air at a particular temperature. Based on figure 1, the particular air temperature is most likely which of the following? Okay, let's just confirm. If it's 20 and relative humidity is 20, right? What was the relative humidity here? 10%, sorry. At 500 hertz, at 10, it is about 8. 500 hertz at, yeah, it's not. 20 and at 500 hertz, it was supposed to be 8, no? Wait, now I'm thinking it could be 0. Could it be 0 though? Yeah, it could be 0 now, I feel. Okay. What about 200? 200, it's 3. At 0, at 200, it is 3. Yeah. So it is 0. The values are closest for 0. Okay. Passage 6, 3 studies compared the effects of 5 sweeteners, sweeteners Q through U on food consumption by rats and on the concentration of leptin and ghrelin, hormones that regulate appetite in the blood of rats. Sweeteners Q to U differ only in the percent of mass by fructose and glucose. Okay. Each of the 5 groups of rats was assigned a solution having 100 grams per liter concentration of one of the 5 sweeteners. Each rat was placed in a separate cage and provided unlimited access to the assigned sweetener solution and to solid food for 56 days. Table 2 shows for each group the amount of sweetener solution and solid food consumed per rat per day. On day 56, blood was collected from each rat for analysis. Okay. In study 2, a 1 ml blood sample from each rat was placed in a separate test tube containing 0.2 ml of indicator N, which reacts with leptin to form a blue dye. The concentration of blue dye in each tube was directly proportional to the leptin concentration in the blood sample. Table 3 shows the leptin concentration per sample for each group. Study 2 was repeated except that indicator P, which reacts with ghrelin to form a yellow dye, was used instead of indicator N. Concentration of yellow dye in each tube was directly proportional to the ghrelin concentration. Okay. In study 1, as the ratio of fructose to glucose in the sweetener solution increased, the amount of sweetener solution consumed per rat per day. The ratio of fructose to glucose. Okay, so the ratio of fructose to glucose increases like this from Q to U. So in study 1, as that ratio increased, the amount of sweetener solution that decreased, right? So it decreased only Yeah. In study 1, the amount of sweetener solution consumed daily by each rat could be measured because which of the following steps had been taken. Okay. The rat's access to solid food had been restricted. The rat's access to solid food had not been restricted. The rats had been placed in the same cage. The rats had been placed in separate cages. So they were, yeah. So it was because they were placed in separate cages, right, that their sweetener consumption could be monitored. Suppose that a sweetener composed of 46% fructose and 54% glucose by mass had been tested in study 1. Based on table 1 and the results of study 3, the ghrelin concentration per sample would most likely have been. Okay, so 46% fructose and 54% glucose. So we are here somewhere, right? 46% fructose and 54% glucose. So we are between R and S. So if you're between R and S, then the ghrelin concentration would be between 1125 and 1279. 1125 and 1279. Okay. Consider the claim the group of rats that consumed the lowest amount of solid food per rat per day was also the group that had the lowest concentration of leptin per sample. Do the results of studies 1 and 2 support this claim? Lowest amount of solid food is group 1, and they actually have the highest leptin concentration, so that's not true. No, the rats in group 1 consumed the lowest amount of solid food, but the rats in group 5 had. So it's C, right? Group 1 had the lowest solid food consumption. Yeah. Which of the following groups of rats should have been included in study 1 to serve as a control for the effect of consuming a sweetener solution on the consumption of solid foods by rats? A group of rats that had access as a control for the effect of consuming a sweetener solution on the consumption of solid food. Yeah, so then they should have had access only to solid food, right? Because if they have access to both sweetener and solid food, then obviously the consumption of sweetener affects their consumption of solid food. So if you remove the sweetener and you only make them consume solid food, then you can compare. What about water? Should they have access to water? Because if I have to compare, yeah, I would have to give them water, right? Because the sweetener is the liquid. Yeah. So I need to give them water and solid food, because then I can compare the effect of sweetener on this thing. Yeah. Consider the sweetener that resulted in a solid food consumption of 16 grams per rat per day in study 1. Based on table 1, how many grams of fructose would be present in 200 grams of this sweetener? So which sweetener was it? 16 grams. So that was sweetener S. And sweetener S has a ratio of 50 and 50. So if there is 200 grams, then fructose is 100 grams. Okay. The experimental designs of studies 2 and 3 were identical with respect to which of the factors listed below, if either they were identical. The chemical indicator that was used, no, the indicators were different, right? Otherwise, they were identical. The hormone with which the chemical indicator reacted. No, that's also different, right? Because the hormone, that's the reason of using that indicator is because, so which of these, they were identical, neither 1 nor 2, J. Okay, so that was the science section. Let's grade it. question starts from question 1. Okay, I'll pull up the answer key. Yeah, 1 second. Z04. Okay, and we are looking at science. DHBGB, DHBGB, okay. 6 FCJCJ, FC JCJ. Okay, so 8 is J. Yeah, 8 is J. Okay, so let's just mark this. We'll come back to 8. 11th, BFBHB, BFBHB, 16, GAHDJ, GAHDJ, 20 is J, okay. Okay, 20 is J. 21, AGCJB, AGCJB, 26, JAFBG, JAFBG, 30 is G. 31, CJBGD, CJBGD, and HCHBJ, HCHBJ. Okay, so we got 38 correct out of 40. Let's look at the first one. Question 8, right? That was the first mistake. 8 and 20. Okay. If another trial had been performed in experiment 2 and 450 ml of liquid had been measured in the cylinder, the temperature of the diet cola in this trial would most likely have been 450 ml. Okay. Experiment 2, and you have wait. Diet cola is changed, right? This is the temperature. So you're doing it between 450 ml of the liquid. Oh, this is such a silly mistake. 450 is below 476. So it obviously has to be greater than 60 degrees. Okay, yeah, so that's clearly, that's a silly error. I'm sure 20th is also something like that. Okay, the average dry mass of, oh my God, the subject is species M. Species M is 3 times as great. I took the subject as species U, and so I said 1/3. Okay, apologies for these 2 silly mistakes, but I hope that the exercise was nevertheless useful. If it was, hit like and subscribe to the channel. With this video, we have completed the solution series for form Z04. I would link to the playlist with all the video solutions to this form Z04 in the description box. So do check those out. All the best for those who are writing the June ACT. I'll see you guys in a new video soon. Take care. Bye-bye.